Okay, guys, so smart materials, here we go. So the definition of these is written here. This is, well, a good way to think of this is actually materials that respond in a certain way to things that happen to them. Um, yeah, because the difference between smart materials and regular materials is that they will then do something when there is, as they call, an external stimulus or an environmental stimulus or something. So there'll be an actual physical change that they'll manifest. So let's have a look. First one is shape memory alloy. These ones are pretty cool, and actually a brand name for one of them is called nitinol. Now, this is pretty cool. It's basically material that will it can sort of be programmed to have a memory, so that if it's then bent out of shape, when heat is applied, it will then go back to its original shape that it was sort of programmed into, as it were. So it's kind of cool, and like the applications you can think of for this are quite interesting. I mean, again, a lot of these materials, people, designers, engineers still don't really. It's kind of like, hey, that's cool, but like we still can't really think. Well, it's not always simple to then actually translate that into a useful application. So, I mean, the example I always give is like, you can imagine a pair of glasses that's made from nitinol. It would be kind of handy because, say, if you sit on them or something and they bend, you could just drop them in hot water and they would just spring back to their original position again. So, I mean, that's like a good example of how they work. Now, one that's similar to this is muscle wire. Muscle wire works slightly differently in the sense that it actually contracts its whole length. So if you had a straight length of muscle wire, when an electric current is applied to it, it actually contracts in length. And you can see here in this video, it gives a sort of example of this working. This is why it's called muscle wire, really, is because it actually shrinks. So I guess the good thing with this is it can be used to actually lift and pull things with there being no mechanical movement. It's literally just the material contracting. So, I mean, I guess that's the really good thing about both these materials, actually, is because there's no need for actual mechanisms. Whenever you get things like hinges or motors or anything like that, you're immediately increasing the complexity and then also the chance of things failing. Another example of nitinol that I've just remembered is it's actually a device called a stent, which is inserted into arteries. It's a good medical application, but so if somebody's artery is blocked, they can insert a stent into it when it's really, really thin and compressed, and then the heat of the blood will then make it change shape. So in the case of a stent, it'll expand, and therefore it'll then open the blood vessel. Then that can just be left in there because it'll stay open. And again, because there's no mechanical moving parts, there's no risk of it failing because it's programmed to be open when it's in a warm or hot environment. So that's really, I mean, these two are fairly similar. They're both kind of classified as shape memory alloys. It's just the stimulus is slightly different in terms of what they do. Now, the next two are both have the word chromic in them. Now, chromic implies color. Thermo implies heat. So if we've got thermochromic pigment, heat, color, pigment, think of it like that. It's basically it's a pigment that can be applied to polymers or as a coating to something which reacts to heat. And then commonly, I mean, we see mugs and things that have thermochromic pigment on the outside, and it like reveals an image or something like that underneath as it heats up or something like that. So there's a lot of uses for both these materials, particularly when it comes to things like glass on buildings and things. So if an architect is wanting a building to automatically dim the amount of sunlight that comes in, say if there's a building that gets direct sun at a certain point in the day and it's blasting straight into the building, they can actually say use thermal photochromic pigment in the glass, which will then automatically dim and darken the glass and limit the amount of sunlight that comes in. But then when night comes, the glass will untint itself again. So this is you can see here in this GIF, you can see like I mean, glasses like spectacles are a very common application of this. Glasses where when you're indoors they are clear, and then outdoors they go dark. Okay, so that's really it for Yeah, for smart materials, I mean, I think really as long as you've got sort of one or two of these dialed, like you'll be absolutely fine